Alright, scholars, welcome back. Time for another fabulously entertaining edition of Module 4 Notes. Go ahead and make sure your name and number are up in the corner as always. Put your title up there, Module 4 Notes. And we will dive in to Module 4, Lesson 22. Lesson 22. Okay. Now for Lesson 22, we'll put our Roman numeral on there. It's going to be a big one. 10, 20, plus 1, plus 2. Okay, so Roman numeral 22. Module 4 is a long one. We're getting some big Roman numerals there. For Lesson 22, we are going to talk about how to compare factor and product sizes. Compare factor, to make that look like an R, compare factor and product sizes. Now we'll start by reviewing some of the vocabulary. Hopefully this is just that, review, and you're going to recognize these terms, but always valuable to make sure we are on the same page. Vocabulary. Okay. The first word we see up here is factor. So let's remind ourselves, what are factors? Factors are the numbers being multiplied. The numbers being multiplied. There we are. The numbers being multiplied together. The numbers being multiplied together in a multiplication expression. Okay. So for example, if I have 2 times 3 is 6, 2 and 3 are the factors. Something times something. Okay, the numbers being multiplied together in a multiplication expression. Those are our factors. So 2 times 3. Which means the next part, our product, is the number I did not refer to in that example. 2 times 3, those are our factors. The answer, our product, was 6. The product is just the answer then. The answer to a multiplication expression. Multiplication expression. There we go. Okay. So I gave you one example already. 2 times 3 equals 6. I'll give you another one. If I have 5 times 12, those two numbers are going to be our factors. As I record this, we've got some rough weather rolling in. I don't know if you just noticed the light change in here. Let's go ahead and see if I can adjust that. Okay. 5 times 12 are the factors. Multiplied together, they equal 60, which is our product. That's our product. Okay, great. So there's our vocabulary. We spent a solid 3 minutes going over stuff we already know, Mr. Landre. Let's get to it. What are we going to do with these things? Well, sometimes when you are looking at multiplication work, especially with fractions and decimals, it can be very useful to compare. We're going to practice comparing factors to products. This is one of those ways where, again, we can test to see if our work is reasonable. Okay? If we can test and check our work to see if we've done something correctly. Comparing factors to products means there are certain tricks you can use to look at the numbers you start with and get a general idea what your answer should look like. Okay? It's a little like rounding and estimating, not exactly, but it's kind of connected to that. What do I mean? Let's take a look at this example. 2 times 16. Okay. Now, we could multiply this whole thing out. It would be 32. That's not actually important right now. Although I guess I probably shouldn't have said that. Sort of gave away the next part. Okay. even before we get the product, we can kind of ask ourselves, will the product be larger? Will the product be larger than the factors? And I already kind of goofed it up, and I told you that, yeah, it will be. And really, when you first learn multiplication, that's one of the first things that normally as teachers we tell you is when you're multiplying factors together, when you multiply numbers together, your product is going to be bigger. You're making things bigger. But as you're getting older, you're moving through 5th grade, you're moving towards middle school, you're going to find that that isn't always true, and there's a reason for it. Now, in this case, it is true. The reason for that, will the product be larger than the factors? Yes. Yes. I underline because of its importance. Yes. Because the factors are both, I'm going to try to make sure this fits. Yes, because the factors are both greater than 1. Okay? So as you're looking at this, and this is not something that you're going to have to write down most of the time, but you can just look at this and say, are my factors both greater than 1? Because if my factors are both greater than 1, I'm going to end up with a product that is bigger than both of them. Will the product be larger than the factors? Well, yeah, because the factors are both bigger than 1. 2 is bigger than 1. 16 is bigger than 1. 5 is bigger than 1. 12 is bigger than 1. Okay. So generally speaking, the opposite must be true, right? If I give you something that looks like this, we'll give ourselves a little space. Let's say I have 1/2 times 16. Now again, a lot of you may already know the answer to this. You might be able to figure out what half of 16 is. You might already know. Okay. I'm going to ask the second question, or the similar question. Let me say it that way. I'm going to ask a similar question. Okay. Will the product be larger than... Now we have to be a little bit careful here. I could have phrased this one the same way, but I kind of wanted you to see the difference. Will the product be larger than the factors? More specifically, will the product be larger than the whole number factor? Okay. Will it be larger than the second factor? 16 is a whole number. 16 is a normal number. The type of number that you've been working with since you were young. Now, fractions are numbers too. 1/2 is a number also, but there's some different rules to it. Okay? And this is one of them. As we're looking at this, do you think the product will be larger than the 16, than the second factor, the whole factor? Okay? And in this case, the answer is no. No. And you can probably guess where we're going with this. It's not because one factor is a fraction. Now, this works for decimals as well. It's really this next part that's super important. Okay, no, because one factor is a fraction that is less than 1. Okay? And if you look up above, remember, I said greater than 1. Well, now we've got a factor that's less than 1. And if you have a factor that is less than 1, okay, a factor that is less than 1, then your product is actually going to get a little bit smaller. Your product is going to get smaller. Now, I can have fractions that are more than 1. If I had an improper fraction, for example, that would be more than 1. That improper fraction might still increase my product. My product might end up being bigger. But because in this case, the fraction, and again, this is true for decimals too, because fractions and decimals are basically the same. If it was a fraction or decimal that is less than 1, my product's going down. Half of 16, 1/2 times 16 would be 8. Okay. So what is our takeaway from all this? We're a little over 10 minutes. We're going to wrap up very quickly. What is our takeaway? What do I want you to remember? Okay. I want you to remember this. If a factor is less, and you know how much I love my bubble letters. I love to emphasize. I think it jumps off the page and helps us remember. I'm going to spend a lot of time coloring this in. Okay. If the factor is less than 1. There we go. If the factor is less than 1. If it's less than 1, then the product will be less. Don't worry, I won't make you do that again. Will be less than the other factor. Okay. And if we think about that, right? 1 times something. 1 times something. 1 times 2 is 2. If I say 2 times 2, okay, now I'm bigger than 1, so my factor gets bigger, right? Okay. Well, my product, excuse me. My factor did go up, but my product got bigger. Okay. 3 times 2. But if instead I say we only have 1/2 of 2, that 1/2, that factor is less than 1, which means my product's going to get smaller. Okay? All right. We're about 13 minutes, so we'll go ahead and stop here. As always, if you have questions, please make sure that you write those down, record those questions, and bring them to our next class meeting. Ladies and gentlemen, have a good day.